Alright, let's look at cylindrical coordinates in MATLAB. And so what we're going to do, I'm going to run this thing and I'll show you what it does. Apparently it takes a little while. So I'll just sit back and relax. There we go. So what I did here is as you can see, I plotted a sphere, or a cylinder, I'm sorry. And so it's made up of, a straight wall and two end caps. And over here you can see, so I did the same thing. I did it two different ways just to kind of introduce you to it. And if I go up here, you can see that, so if I look at the end of it, I'm doing for different values of r. I'm calculating x and y and for the various values of phi, right? And then on the sidewall here, r is constant, and I'm calculating it for different values of z and phi. So once again, when I do the sidewalls, r is constant, and I'm going for different values of phi and different values of z, and plotting all these dots. And then when I do the end caps, z is constant, and I have varying values of phi going around this way and r going out this way. So let's see how I did that. So let me just put a breakpoint here, and so I have a resolution, a linear resolution, and I have an angular resolution. So my linear resolution is going to be 0.1, let's call it meters, and my angular resolution is going to be 5 degrees. Now you'll see up here that I have this value pi over 180, and it's called d2r, right? d2r. And that's pretty important because all the MATLAB cosine and sine functions, they use radians, and I like to work in degrees because degrees mean more to me. So if I take 90 degrees times d2r, that's degrees to radians, you can see it's 1.5708. That may not be quite as clear to you, but let's say we do 180. So if I do 180 times d to r, you can see that's 1 pi, and if I do 360, I get 2 pi. So now here I have all of the z values. So I'm going to do z from -1 by my linear resolution to 4. And so you can see z starts at -1 and it's 0.1 increments. My phi is going to be 0 to 359 degrees, and it's going to be my angular resolution, which is 5 degrees. So now let's just step through here. So I'm going to step. So the first thing I do is I generate this figure. Next thing I do is I generate an axis on that figure, and notice this is a plot 3. So this is how you plot in 3 dimensions in MATLAB, just in case we haven't quite got there with any of the previous lessons. And I just plotted a nan, a nan, and a nan. Nan is not a number. So if I take I think if I take 1 and divide it by 0, I get infinite. So, but n is not a number, and when you plot a not a number, you don't get anything. So I don't, I have just an empty axis there. And I'm going to go ahead and put the grid on that, and put the rotate 3D on. Okay, so now there you can see the axis. So let's step through this. So I want to look at all the z values. Okay, so I picked out the first z value, which is -1, and then I'm going to get the phi values. So I have a z of -1, I have a phi of 0. I'm going to calculate the x value for that, so that's going to be r, which is a constant, times the cosine of phi, but that's in degrees, and I need to convert it to radians. So that gives me x is it's going to be 2 then. My radius was 2, no doubt. Yep. And y is 0. And now I'll plot that point. And so I don't see it on there, but I'm sure it plotted it. Where's that exactly? But I'm sure he's in there somewhere. So let's just do a few more. Okay, now let's take a look at this plot. I still don't see anything. Well, that's peculiar. Oh, wait, there they are. There, I gotta see them. Okay. Um, so we can plot a few more. Okay, and okay, so there they are. There they are. They're kind of hard to see. Oh, yeah, okay, there they are. So let's just go plot them all now. So we'll hit continue here. And so it takes a little while because it has to go through this. So there's a lot of calculations here. You're calculating the sine and cosine a lot. There we go. And so there you have it. So there's all of the values that I plotted. Plus I'm plotting them, and that takes a little time. So that's not the most efficient way to do it, but it's certainly the most straightforward way. So there you have the shell. Next I have to do the end caps. So I'm going to do the bottom first. So I'm going to set z equal to z1, right? Because that was -1, that was the bottom one. And then I'm going to do the radius 0 times the linear resolution times r. And then I'm going to step through all of the values of phi. And this time I'm going to plot them in green, right? So let's plot a few of them. And let's see what we got. There they are. They're all down there at the bottom. So it's plotted those around a ring, and they're not very far apart. Maybe I can, let's try to go here. So let's continue. Yeah, there we go. Okay, so let's see what that looks like. Okay, there you go. So now you can see I'm plotting these rings, right? And so I did, looks like I got the bullseye. 1, 2, 3, 4 rings. Okay, so let's do another ring. Okay, so now there's the bullseye, and there's 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6. All right, and you can see that that's the bottom I'm working on, which is what I thought I was going to do, right? So let's let this guy go. Continue, and voila, there indeed is the bottom cap. And I probably replotted, so I plotted some green ones over top of some blue ones, but that's okay. And then I can do the same thing for the top. So let's continue to do that. Okay. And what do we got? Yeah, so now we have both the top and the bottom plotted. That's pretty easy, right? And then if you wanted to calculate the area, let's say of this straight side, then what you would do is you could just, for each of these squares, you would multiply by r d phi, and for the width across the dA, and then you would multiply by dz in the up direction to get the incremental area of that, and then you would just add them all up. Okay, so now I want to do it a different way. So this time I want to do mesh grid. Okay, so here I have my z values, and here I have my phi values, right? So there you go. So it's 51 by 72. And I don't think we've used mesh grid before, but let's look at the help on mesh grid just to see what it says. So it says mesh grid, you give it 2 variables and you get 2 variables back. And you can also do it in 3 dimensions, so you can give it a group of x values, a group of y values, and a group of z values, and it will return back. What does it return back? Well, let's take a look here. So I need to step once to get over that. Okay, so what this does is see, this was 51, and this was 72, and so you see it gives me the 72 by 51 grid. So it actually so here are all of the z values, right, from -1 all the way up to 5, up to 4 in columns. And let's look at and so the phi values then are going the other direction, and they go from 0 to 51. So if I go out here somewhere, maybe let's say a 10, 2. This point is going to be 45 degrees, and it has a corresponding point, 10, 2 of 0.9 in the z direction. So this is how I get a z value and a phi value for every one of the points that I'm going to plot. And so while that may look a little more complicated, look what I can do now. I can take the r value, multiply it by the cosine of this mesh, and this will do it element by element. And so with one click, I've actually calculated the entire array of 72 by 51 points, at least the x value for those points in one statement. And then here are all the y values. So here are all the points, the x and the y values for all of the points in that cylindrical shell. And to plot them, then I just generate a new figure. Okay, there we go. And I plot the values, and there they are. And then I need to turn the grid on, because I always like to have a grid. If you'll notice, this thing is, this is 4, and this is 5, and you can see that they're, it's not, it's a long, tall cylinder, but it doesn't look that way. So if you say axis equal, then it sets all of the axes to the same value, and that's what I get this nice, tall cylinder. And so now I can just go ahead and step through here, and there I have it. There's the x, the y, and the z axis, x, y, z, and there's the cylinder. So now I can do the same thing for the end caps. I'm just going to do the mesh grid, but this time I'm going to use the r values. So here's my r. Here are my list of r values from 0 to r, and my list of phi values. And so now I have another set of matrices that give me the radius and the angles for the end cap. And then I can use the same two formulas here. This time, the only difference is I'm going to take this one and multiply by 0 and add z1 to it. So so here I have the x values, the y values, and the z values, and it's the same thing. If I look at the x values, this x value right here, let's say 10, 2, is going to have this y value, 10, 2, and it's going to have this z value, 10, 2. So this is going to, all the z values are -1, and so now I can plot that. And if I look at my plot now, so I have the bottom end cap. And then I'll do the same thing for the top end cap. Okay, and that completes my cylinder. All right. Now, let's take a look at the, we'll calculate the area. As we looked in the slides, we noticed that the incremental area was the dz, so that's the vertical direction, times r d phi, which is the horizontal direction. And so I'm going to have the area of the cylinder, so I'm going to start that out at 0, and then I'm going to go over all the z values, and I'm going to go all over all of the phi values, and I'm going to add those up. So this is going to go through the loop 51 times, and this is going to go through the loop 72 times. And so let's continue down to here. So I've calculated dA, which is dz, right? So 0.1 times r times d phi, and so here you can see d phi. I multiplied it by d to r before I did that, so it was actually 5 degrees, but that's the angle in radians. So you need to remember that anytime you're looking to do a calculation, it typically has to be in radians. So there's dA. And so I'll just go through and I'll add all those guys up. And so let's continue down to there. All right, so I initialized it to 0, and I go through this loop, and I'm integrating them all up. So continue down to there. And so here's the area of a cylinder. So it's 2 pi r, right? That's how big the diameter is. 2 pi r. That's the distance around the cylinder. And then times h, right? That's the formula for a cylinder. And so I have I calculated 62.8, and it's actually 62.8. So I did pretty good. And I did a few things here, like I went back. I didn't do every value of z because that would be one too many, right? So if each of these dots represents a little square of area, I don't want to do the last one because that's going to put it over the top of the cylinder. And then I can do the same thing for the top. So I set the area to the top to 0, and then I go through all the r values, and I go through all the phi values, and I calculate the dA. And so that's r1 times d phi times the resolution, and so that gives me the top area. I'll go ahead and go through all of those. And so the true top area is just pi r squared, right? That's the area of a circle. And here's what I've got. And so you can see that I've got a pretty good answer there. And then I can do the same thing for the bottom. And so there's the area of the bottom. It's the same calculation. And then I can add them all up. And you can see that I got the area to within that little tiny fraction. So, if I were to assign you this, which I'm going to do for the sphere, I'll give you the volume of a cylinder and the area of a sphere to do for homework, and you can do those. But if you've come up within, a percent or two, you've got the problem correct. All right. So I'm about out of breath, and I'm going to turn you loose, and we'll take a look at some spherical calculations next.